the early 1900s, America's frontier was closing. The great westward expansion had ended at the shores of the vast Pacific Ocean. As the 20th century dawned, President William McKinley was killed by an assassin, and young Theodore Roosevelt was suddenly president. Among Roosevelt's major initiatives was to declare large sections of the West as reserves and parks, saving them from the ravages of a greedy logging industry. Teddy Roosevelt was the first president to introduce a national agenda in conservation. He established the U.S. Forest Service to oversee the wilderness, and he enlisted naturalists and scientists for direction in managing these resources. At the same time, along the Pacific coast, a new frontier was opening to scientists who wanted to explore the oceans. Among them was a biologist and social philosopher, William Emerson Ritter, who believed that to unlock the secrets of life in the sea required an understanding of the complex interrelations between marine organisms and their surrounding environment. He wrote, "No segment of the phenomena presented by a marine animal is fully understood until it is regarded in the light of the entire life career of that animal. We must learn, through careful and extended observation of the animals in nature, just what it is we have to interpret." William Ritter's pioneering efforts in marine biology evolved into a new science of ocean ecology in the classrooms and laboratories of the West Coast. And at no location was this genesis more profound and far-reaching than at the small laboratory he established in San Diego, California, that became Scripps Institution of Oceanography. The beginnings of Scripps Institution were humble but visionary. In 1893, Ritter joined the zoology faculty of the University of California at Berkeley, which in those days was the only UC campus. He had conducted graduate studies in zoology at marine labs on the East Coast and in Europe, and soon after coming to Berkeley, decided that his life's work was to create a marine biological station on the West Coast. In pursuit of his aspiration, Ritter began a series of summer field sessions during the late 1890s. Setting up camps from Monterey to San Pedro, he examined the marine life and habitats along the California coastline, while seeking a suitable site for a permanent station and the backers to support it. He was accompanied on these summer trips by groups of students who were attracted by Ritter's charisma and infectious enthusiasm for his research and instruction. In 1903, Ritter came to San Diego at the urging of Fred Baker, a physician and avid shell collector, who solicited funds from the business community and arranged for the use of the boathouse at the Hotel Del Coronado as a laboratory. Ritter and 9 investigators spent the summer collecting and analyzing samples, using a small fishing boat for excursions in San Diego Bay and along the coastline. Their activities at the boathouse drew interest among the vacationers to Coronado and local community members. The biologists would often stop to explain their work to the visitors who stopped by. Among those who became interested were newspaper tycoon E.W. Scripps and his half-sister Ellen Browning Scripps. The Scrippses had moved to a San Diego ranch in the 1890s from the Midwest, where the family had made a fortune in the newspaper business. Miss Ellen was in her 60s at the time, and her interests were turning toward philanthropy. Her half-brother, E.W., was 20 years younger, and while he remained actively involved in his newspaper enterprises, he spent considerable time sailing and enjoying a genteel lifestyle. The two met Ritter and took a keen interest in his marine studies and an immediate liking to the affable scientist. At the end of the summer of 1903, Ritter, Baker, the Scrippses, and 30 other San Diegans formed the Marine Biological Association of San Diego. Among its purposes were to carry out a survey of the coast of Southern California and to build a public aquarium and museum. Ritter said at the time, "There can be no doubt that a laboratory capable of great things for biological science might be built at San Diego." Over Over the next 2 years, a small laboratory was established at La Jolla Cove, and year-round studies were begun in 1905 when Ellis Michael was hired as the resident naturalist. He oversaw the lab as Ritter continued teaching at UC Berkeley. Soon, other Berkeley faculty members started working at the innovative laboratory, and in 1907, Edna Watson became the first UC student to study under Ritter in San Diego to receive a doctoral degree. Short cruises were taken on private yachts and fishing boats until the 85-foot Alexander Agassiz became the institution's first ship built for ocean research. In 1910, the institution's first permanent building, named the George H. Scripps Memorial Marine Laboratory, was completed on an isolated stretch of 170 acres along the coastal cliffs of La Jolla shores. The Ritters moved into the building, and in 1912, the institution was deeded to the University of California. For the first few years, marine plants and animals in jars were set out for the public to view. And the first aquarium building opened next to the main lab in 1916. The financial and intellectual contributions of E.W. and Ellen Scripps were critical to the fledgling marine lab. They funded the library, cottages for faculty, staff, and student homes, various ships, and the original pier. E.W. took an active role in the daily management of the institution and promoted Ritter's causes with the UC administration and state officials. E.W. and Ellen's role was recognized when the Regents of the University of California adopted the name Scripps Institution for Biological Research. Speaking of the new marine lab, E.W. said, "We're going to make this the biggest thing of its kind in the world." More students arrived and research focused chiefly on biology. But soon the scope of the studies grew as physical oceanography and marine geology were added. Ritter directed the research and teaching program at Scripps for 20 years until his retirement in 1923. The 1920s were a time of unbridled growth. Industrialization and mechanization were in full swing, and it seemed as if modern times had arrived. At the Marine Station in La Jolla, geologist T. Wayland Vaughn became director. Vaughn had worked for 30 years at the U.S. Geological Survey as a field scientist and administrator, and was among a small group of experts on marine sediments. It was a time of great enthusiasm. A new ship was acquired, and new scientific initiatives proposed. Vaughn's vision was to broaden the institution's research objectives by adding studies in sedimentology, chemistry, and bacteriology. These efforts were recognized when the institution's name was changed to Scripps Institution of Oceanography, thus becoming the first general oceanography research center in the nation. But within a few years, the Great Depression thwarted scientific developments at Scripps and beyond for nearly a decade. While the Depression hindered growth of research programs, Scripps grew academically, adding faculty who developed curricula in areas of marine science that had never been taught before. Growing numbers of students came to the campus, as many as 13 per year, and Scripps became the first U.S. school to offer a graduate degree in oceanography. From time to time, scientists from the small institution joined research expeditions far and wide. In 1936, Norwegian oceanographer and Arctic explorer Harald Sverdrup was appointed director of Scripps Institution. Sverdrup was committed to turning the then remote marine station into a world-class oceanographic institution. He began by convincing the University of California to increase its financial support, and by establishing cooperative research programs with state and federal agencies. He was helped in these efforts by E.W. Scripps' son, Robert Scripps, who who also increased family donations and gave a 104-foot schooner to the institution, which was renamed E.W. Scripps. The ship allowed the scientists to take research cruises farther out to sea and on their longest expedition, a 2-month voyage to the Gulf of California. In 1942, Sverdrup, Martin Johnson, and Richard Fleming published the first textbook about oceanography. The oceans, their physics, chemistry, and general biology. The institution was small, but growing steadily. And before long, world events changed the development of Scripps and the science of oceanography. World War II. Facing a German submarine offensive in the Atlantic, the Japanese fleet in the Pacific, and untold numbers of beachhead landings, the Allies determined that they needed to know more about the oceans. Scientists were called upon to help turn the tide of the war. The University of California set up a war research division in San Diego, and many Scripps scientists assisted in the military efforts, while others went off to active duty. The faculty conducted training courses in sea, swell, and surf forecasting for military officers, and the Navy sponsored many new areas of research related to waves and ocean physics, sonar and underwater acoustics, and ocean forecasting and meteorology. There were many advances. Director Harold Sverdrup and graduate student Walter Monk developed methods for predicting surf conditions that were put to use by the Allies during landings in North Africa and Normandy, saving hundreds, perhaps thousands of lives. Biologist Martin Johnson identified the cause of a false bottom interfering with the sonar on submarines as being a natural layer of tiny organisms, giving Allied submariners the advantage in detection and concealment. Techniques and devices for measuring the propagation of sound and light in the ocean were developed, as well as instruments for seafloor magnetics, seismology, and geophysics. Sverdrup concluded, "The war showed how oceanography could be applied." Victory came optimism, prosperity, and a new world order. America went back to national interests, and on the West Coast, the resources of the Pacific Ocean seemed bountiful and unlimited. The California sardine fishery became the world's largest fishing industry, and the Monterey canneries ran around the clock. Then suddenly, in the late 1940s, the sardines were gone. Was this the result of overfishing, or some natural fluctuation in the cycle of marine life? Scripps received $300,000 in state funds to pursue the mystery by joining with the California Department of Fish and Game and the National Marine Fisheries Service in studies of the California coastal ecosystem. The project, called the California Cooperative Oceanic Fisheries Investigations, began a series of ocean cruises every 3 months to measure marine life abundance and to collect data on the physical properties of the ocean, forming what has become the most comprehensive study of an ocean ecosystem ever conducted. In the period following World War II, Roger Revelle emerged as a prominent figure at Scripps. He was a Scripps graduate and naval officer who had served chiefly in Washington, where he helped organize the Office of Naval Research. When he returned as a professor and associate director, Revelle helped secure 2 former Navy ships for the institution. In 1951, Roger Revelle became Scripps Institution's director, with a vision that ocean research could help solve such world problems as food and mineral shortages, contribute to national security, and provide data basic to understanding Earth processes. Revelle took this message to the nation, becoming an ambassador of ocean sciences.
Our guest today is one of America's foremost oceanographers. He is Dr. Roger Revelle, director of the Scripps Institution of Oceanography. Talking with Dr. Revelle now is Dr. Julian Goldsmith of the University of Chicago.
Care to give us a few examples, for example, of what the science of oceanography encompasses? Well, I think the simplest thing to say is this, that an oceanographer is a scientific sailor. Oceanography is a science that you do at sea. But another and perhaps more useful definition is that oceanography is the application of the basic sciences of physics and chemistry, mathematics and biology to that part of the earth which is covered with water. The bottom of the sea, the shores of the sea, the atmosphere above the sea, the waters themselves, and the creatures that live in the water.
Revell used a chalkboard and simple illustrations to explain ocean and earth processes, and the program gave him a chance to philosophize about science.
Do you have, as a scientist, any particular concern that might relate to your relationship to the non-scientist?
The really most critical problem of our time, and of course we live in the midst of many critical problems, many of them created by science and technology, is the problem of somehow adapting ourselves to the new age which is being created, not rejecting it, not wishing that we could go home again to some never land of the past, but somehow building up the courage and the fortitude and the vision to face the future that our increasing understanding of ourselves and of the universe will bring.
With increasing government funding, Revell oversaw a great expansion of investigations and research programs at Scripps in what became known as the Great Age of Exploration in Oceanography and Earth Sciences. Scientists were beginning to view the Earth as a continuously changing system with a long history of evolution and cataclysmic events and a somewhat uncertain future. The whole Earth was becoming a laboratory and classroom for Scripps science. Scripps scientists had used hard hat diving in the 1940s, but when the aqualung was invented, it provided a new way to explore the shallow ocean. Conrad Limbaugh was among the first to use scuba for scientific investigations. He worked in the kelp forest and developed early techniques for underwater photography. Scripps was instrumental in creating safety guidelines for diving and contributed to the creation of the wetsuit. In the 1950s, under Roger Revell's leadership, the institution went to sea in a big way, beginning with the first major Scripps expedition, mid-pack, to the Central Pacific Ocean. Scripps scientists discovered the world's largest geological feature, the submerged mountains of the mid-Pacific. They measured variations in the Earth's magnetic fields under the oceans to explain plate tectonics. And they drilled into and sampled the seafloor, revealing an ancient storehouse of geological history. During these expeditions, Robert Fisher, a Scripps geologist, confirmed the deepest spot in the oceans, the Challenger Deep in the Marianas Trench near Guam. Studies of marine ecology expanded into unexplored regions in the North Pacific, where an abundance of sea life was discovered. Many new instruments were developed, including the first successful trawling device for capturing marine animals in the deep water, designed by John Isaacs, who also developed the first camera for taking motion pictures of deep sea life. Nicknamed the Monster Camera, it attracted animals by using a pole with bait on it.
The camera system weighs approximately 200 pounds in air and must be deployed by use of the ship's crane. Upon launching, the ballast weight pulls the vehicle to the bottom. The following sequences are the results of our latest efforts. They were taken off Southern California and Central East Africa. This sequence was filmed in the San Diego Trough at a depth of 3,900 feet. Sablefish are the most predominant fish seen at these depths. A few grenadier appear in these scenes, and of course, hagfish are ever present.
Groundbreaking research also began in marine geology. New techniques were developed for sonar and seismic studies of the seafloor and exploration of the underlying sediments and oil deposits. More advanced mechanisms for measuring coastal processes were developed, and electronic sensors and digital data collection were introduced to tide and wave studies. Scripps microbiologist Claude Zobel discovered that bacteria live throughout the oceans, including the very deep sea. Geologist Russell Raitt found that the thickness of the Earth's crust beneath the Pacific was less than predicted, and biologist Carl Hubbs greatly increased the knowledge of Pacific fishes and made pioneering studies of marine mammals and their conservation. An avid field scientist, Hubbs was considered to be America's greatest fish expert and delighted in teaching students about fish and marine biology. In 1963, a science teaching film was made of Hubbs aboard research vessel Spencer F. Baird.
Today, we invite you to meet ichthyologist Dr. Carl L. Hubbs, professor of biology at the Scripps Institution of Oceanography of the University of California at La Jolla. The Spencer F. Baird, just back from the Indian Ocean, makes her steady 10 knots, her twin diesels driving her easily through the long swells of the Pacific. Crew, students, and Dr. Hubbs give their attention to the mid-water trawl.
And going overboard is the feeder net, very fine cloth that will strain out virtually microscopic organisms in the water. We can look right down into the mouth of the net. That's the way the fish go into it. This net will descend to a hauling depth of 600 fathoms, which is 6 times that, of course, in feet, 3,600 feet. And the temperature of the water is down a little above freezing. There is no light, there's virtually no light penetrating from the surface to that depth.
Now the long wait, the test of fishermen's luck. Perhaps strange creatures will be taken, perhaps not.
Watch it. There we got a hagfish near the trap.
Professor Hubbs discusses with his students some of the weird sea creatures caught in the trawl.
We have quite a number of these lantern fishes. These are phosphorescent fishes, luminous fishes. These white spots here are light organs. Here's a very peculiar one. This one we've given the common name of fangtooth, and you can see very well why. There are enormous fangs on him.
The interest in oceanography is worldwide, growing every day. Dr. Hubbs points out that the sea will one day be the major source of protein food, that the nation which knows most about its deeps may very well be the nation to lead the world. There are great challenges here. Dr. Hubbs accepted these challenges years ago. Today, he helps his students meet those challenges. Among the objectives of ABC Public Affairs and the presentation of this continuing series are to present the professor in the context of the campus, the community, the nation, and the world, to show the complex resources he and his students use and require. We trust your meetings with Professor Hubbs have served to further these objectives.
By the mid-20th century, it was evident that the burning of fossil fuels since the beginning of the Industrial Revolution was contributing to changing Earth's atmosphere. Industrialization and transportation were producing massive amounts of carbon dioxide and other pollutants. But no one understood fully where in the environment they were going. During the International Geophysical Year in 1957, Scripps launched a program to monitor carbon dioxide in the atmosphere under the direction of Charles David Keeling. Air samples from around the world were sent to Scripps for analysis. By the 1960s, Keeling provided the first evidence of a buildup of atmospheric CO2, a major factor in the greenhouse effect in global climate warming. Expanding programs in the 1950s required new facilities, including a larger, more modern aquarium and museum for the public. The new Scripps Aquarium quickly became a San Diego landmark, where millions of visitors and school children were introduced to the ocean world. In the 1960s, the University of California, San Diego was established, largely through the efforts of Roger Revelle and other Scripps faculty. Scripps Institution became a graduate school of UCSD. In 1962, the world's most unique seagoing vessel, research platform FLIP, was developed by Scripps. FLIP, for Floating Instrument Platform, is towed out to sea in the horizontal position, and then slowly flipped to a vertical position by water flooding into its large ballast tanks. Once upright, FLIP provides an extremely stable platform for ocean studies. Never duplicated, FLIP remains in service today. The 1960s were a time of many long-range expeditions to the Indian and Atlantic Oceans, around the Pacific Rim, and up the Amazon River. Among the principal investigators was Walter Munk, who studied at Scripps and then stayed on as a professor. Munk directed the Waves Across the Pacific experiment in 1963, from which he showed that the source of very long-period Pacific Ocean swells was in the Indian Ocean.
Dr. Walter Munk, director of the laboratory, originated this study of energy, waves, and the sea. With his colleagues, he spent an entire summer tracking waves generated by the severe Antarctic storms. This was the first time that men had simultaneously gathered precise and detailed wave data over global distances.
We wanted to see if we could identify a train of waves from storms in the Antarctic region all the way to the beaches of Alaska. We particularly wanted to study the processes by which wave energy is lost. At last, 6 locations were selected along a great circle route 10,000 miles long, stretching across the entire Pacific. The volcanic islands of Samoa, where a favorable wave exposure was found along the exotic southwestern shore of Tutuila. On July 8th, the waves arrived as expected. We lived in a Samoan folly on the edge of the village. The house was built entirely of coconut palm, an ideal place to work on waves. The house was open on all sides. It afforded lots of comfort and no privacy. To operate our recording equipment, we had taken along our own generator. As at all the stations, we recorded for 3 hours twice each day, from 4 to 7 a.m. and from 4 to 7 p.m. Each day we punched out 10,000 data points to be digested by the computer at home. We hardly ever missed a measurement. The equipment worked admirably, and my initial apprehension soon vanished. Data taking became quite routine. My wife and some of the Samoans learned to operate the recording equipment. Our measurements indicated some loss of energy between New Zealand and Samoa, but lots of wave energy remains. When at the end of the summer we finally returned to California, we had amassed 10 million data points documenting waves from 12 major storms. A person with a desk calculator would have taken 2,000 years to convert this data into a meaningful picture of what happened. With a high-speed computer, our analysis was finished within a week of the end of the expedition. Plotting the spectra for the storm waves, we see a sloping ridge showing again the early arrivals in the low frequencies, followed on subsequent records by higher frequencies. This can be seen more clearly in a three-dimensional model. The data amassed from station to station shows that for this storm we have succeeded in characterizing the wave climate across the entire ocean. On the basis of observations in Samoa, we could predict surfing conditions in Hawaii 3 days in advance. Our principal aim, however, was to learn something about the attenuation of waves, to compare the energy of the ridges from station to station. In talking things over, we're pleased with how well these storms were documented by the experimental program. We are somewhat disappointed that the measured attenuation varied considerably from storm to storm, but this should be no surprise, for in nature no two storms or no two waves are ever alike.
In 1964, William Nuremberg became Scripps director, launching an age of high technology, acquiring new instruments, computers, and remote sensing devices on ships, buoys, and satellites. He pursued national and international programs and brought about a 5-fold increase in the institution's annual budget. TV producer Bill Burritt made an hour-long documentary about Scripps that piqued public interest in the institution and oceanography.
The oceans of the world are now recognized as a vast, untapped reservoir, not only of food, but also of knowledge. The study of the oceans is called oceanography. It's one of the most intriguing fields today, and we're going to explore it. The world of oceanography.
These students gathered in 1903 at the biology lab, which was to become one of the world's foremost centers of oceanic research, Scripps Institution of Oceanography. Today, Scripps sprawls across the old site above the scenic coastlines at La Jolla, near San Diego, California. Now a branch of the University of California, Scripps attracts top students from all over the world to its spectacular campus, where space-age research now tackles the secrets of the sea. Oceanography today is a vital, exhilarating science. Yet an air of easy informality lingers on at Scripps, and it's difficult to tell professors from students in the casual setting of impromptu outdoor conferences and seminars. Students mingle here with renowned scientists, experts from many fields of study. While in classroom sessions, others absorb the complex ideas of mathematical physics, among the new tools for comprehending the behavior of the oceans. Marine chemistry student Ray Weiss describes his involvement in oceanography.
I began my work as a chemist, as an undergraduate, and I became interested in applying what I had learned to studying processes occurring on the Earth. Many different things were being done here involved in what we call geochemistry. Once here, I became very interested in working directly on the oceans and applying some of the modern techniques which have been developed in recent years to learning more about the deep oceans.
With the ocean at their doorstep, Scripps students spend much of their time at sea. Scuba diving is an almost daily routine for young graduate students, Ann Hartline and Alina Zaman. Ann, a marine ecologist, tells us how she discovered oceanography.
I'm not sure where I really started first getting interested in oceanography. It was probably since I was a kid in the Midwest. I came down to Scripps and started working in the field of marine ecology. People just, they didn't even know what the word was. My parents, people like that, when I first started. And I sure hope that it does some good as far as things like pollution and things that people say they're worrying about are concerned.
Ann's concern for the environment is representative of that of many younger students of oceanography, vitally involved not only in research, but in improving man's relationship to the natural world.
The show also featured the activities of the Scripps fleet and the work conducted at sea.
This is applied oceanography at its most strenuous. Scientists and technicians may work long hours, often in high seas, in order to retrieve only a few samples of mud and rock. Yet, this too is part of the romance of oceanography, a rare combination of adventures of theoretical science and back-breaking effort. The future of the science and of Scripps may be best reflected by the comments of Dr. William Nierenberg, director of the institution.
The exciting thing about Scripps Institution of Oceanography is that because of its size and wide diversity of interests and disciplines, it interacts with all levels of society and essentially all units of government, city, county, state, federal, of course, other governments and international organizations. And the thing that has impressed itself in an extraordinary way upon me is the fact that in the last 10 years or so, there has been a tremendous upsurge of interest in the oceans and in the science of oceanography at all levels of society, the man in the street, the members of parliament, and in all countries.
While man rushes into space in an effort to understand the cosmos, oceanographers are patiently trying to chip away the mysteries of the sea, to understand our own planet more fully. As land resources fail and the world's population booms, the sea gains daily in importance. Man's future is ultimately tied to his success in understanding and harnessing the great potentials of the sea. So, oceanographers are both explorers and pioneers in a world which will become increasingly familiar to all of us, the challenging world of the sea.
In the 1960s, the age of hand-me-down ships ended with the addition of a series of nearshore and large-scale research vessels specially built for global ocean science, including the Thomas Washington and the floating biological laboratory Alpha Helix. The Navy gave Scripps the Nimitz Marine Facility on San Diego Bay, which became home port to the institution's growing research fleet. The Deepsea Drilling project, one of the most ambitious marine science programs ever conducted, got underway in the mid-1960s, with Scripps chosen by the National Science Foundation to lead the multi-institutional international project. The massive drilling ship Glomar Challenger was sent around the world for nearly 15 years, collecting long cores of seafloor sediments that helped revolutionize scientific thinking about the Earth's history and the character of the seafloor. The project's director, Melvin Peterson, explains.
And indeed, as was predicted by the theory of seafloor spreading, the age becomes younger near the central part of the ocean, for example in the Atlantic Ocean, and is progressively older as one moves closer to the continents. And this is the result of a motion of the seafloor spreading away from a central ridge where the seafloor is being continually produced. And of course, the most important thing we are doing is bringing back samples. To a geologist, there is nothing quite like a sample. And these samples receive a great deal of study on the laboratory of the Glomar Challenger and then also in laboratories associated with the Deepsea Drilling project. In addition, it is hoped that these samples will be studied for many years to come. The results of our work get published in reports appropriate to each of the 2-month cruises of Glomar Challenger.
At the same time as the Deepsea Drilling project, Scripps scientists led many other expeditions around the world. Robert Fisher made a film of the Circe Expedition in 1969.
These are exciting, even revolutionary times in the Earth's sciences. Older ideas are being re-examined, modified, discarded, and new hypotheses or even theories being advanced to explain how our Earth works. Circe Expedition will be an attempt to collect geological and geophysical materials to elucidate these and many other questions. We shall use Argo of the Scripps Institution of Oceanography. We shall concentrate our work in the Indian Ocean, where conditions seem most favorable for our studies, and that continents, mid-ocean ridges, continental fragments, and subcontinental or intermediate masses lie fairly close together.
shall also work intensively in the South Atlantic. While the emphasis will be on geological and geophysical collections, we also shall study the biology of the midwater masses, the characteristics of surface currents, the age and composition of the deeper waters, especially in the South Atlantic. But now, let's sail with Argo.
Thus, on a drizzly afternoon in March, Argo sets sail on Circe, a cruise that will take her around the world in 330 days. The initial segment of every long cruise is a shakedown of ship, people, and equipment. Standard gear is in operation, logging observations, while new devices are field tested and new methods of handling gear are tried. Striking westward across the Pacific, Argo investigates the steep scarps and irregular basins west of the Marianas Island arc. With Argo drifting, or at very slow speed, the dredge is dragged on the bottom for 1 to 3 hours. Talus, boulders, or ledge rock are gathered or broken off and collected in the chain bag. A full bag comprises nearly a ton of rock. The usual haul is much less. Ahead lies Mauritius, a volcanic island almost directly through the earth from Southern California. Basing at Mauritius, Argo undertakes a detailed geological study of a 2,000-kilometer segment of the mid-Indian Ocean ridge. Early in October, Argo rounds the Cape of Good Hope into the Atlantic, carrying scientists from 4 nations and 5 research institutes. 2 months and lots of hard work, some in stormy seas. Northeastern South America is in sight, and low islands mark the harbor of Fortaleza. Here, most of the scientific staff will return home, while a new team takes over and emphasis shifts to work nearer shore. On the Rio Magdalena Delta north of Colombia, soupy sediments are collected with 2 pipe dredges welded together. Transiting the Panama Canal, Argo rounds third and heads for home. Even after these 58,000 nautical miles, Argo looks trim as decks are cleared and lines made ready for docking. Point Loma, sheltering San Diego Harbor, rises on the port bow, and Argo heads into the fairway. No fireboats, but the smallest ship in the Scripps fleet accompanies her up the channel. Back at Scripps Marine Facilities, the wharf is cleared, officials are alerted, and the news media are on hand. Argo eases into her berth. The first line is heaved from her foredeck, and the mooring lines run out and secured. The gangway's rigged for clearance by health, immigration, and customs officials. The all-clear is given and barriers are dropped. At this moment, no one cares that Argo has sailed a distance much more than twice around the globe, or that 85 scientists and 65 crewmen have been aboard at one time or another during Circe. This day marks only the first, most obvious close of Circe. Work on her samples and records will occupy scientists from Scripps and laboratories around the world for many months or perhaps years. Scripps director congratulates Argo's captain. So Argo rests until another time, another team, a different challenge, 2 months hence.
Nuremberg established a climate research group at Scripps under the direction of long-range weather forecaster Jerome Namias. Using data on the atmosphere and sea surface temperatures, the group made predictions of winter weather conditions that were used to help make decisions about resource allocations, farming, and storm damage prevention. To better monitor and understand ocean conditions, the North Pacific Experiment sent ships and buoys out to sea throughout the 1970s. This increase in data on sea surface temperatures and the atmosphere over the oceans provided a much greater understanding of air-sea interactions. In the early 1970s, the National Science Foundation organized the International Decade of Ocean Exploration, which contributed to several programs at Scripps, including many expeditions to faraway regions of the world's oceans. On these expeditions, Harmon Craig and his co-workers measured the concentrations of natural chemicals in the water as a means of tracking subsurface circulation. During the 1970s, Scripps made several expeditions to the Eastern Pacific. Geophysicist Fred Spies was among the research leaders, and he developed DeepToe, which was towed behind a ship to photograph, measure, and sample near the deep sea floor. In 1976, researchers using DeepToe confirmed hydrothermal activity on the East Pacific Rise and photographed animals that proved to be new life forms. Later expeditions revealed these sites of hydrothermal activity to be inhabited by strange animals that thrive on energy from seafloor chemicals rather than sunlight, unlike any other community on Earth. At the same time, other developments were giving scientists a new ocean view. The late 1970s ushered in an era of space exploration that led to many spin-offs of Earth and ocean sciences. For the first time, we could leave Earth or send up remote sensing instruments to observe the oceans from space. In 1979, Scripps officially entered into space-age oceanography with the opening of the first satellite tracking station at a marine institution. The facility gave oceanographers a detailed view of the global oceans and worldwide environmental conditions. As Scripps grew, so did its reputation. Famous visitors included Emperor Hirohito of Japan, underwater explorer and filmmaker Jacques Cousteau, and later, Great Britain's Queen Elizabeth and Prince Philip. In recognition of Scripps's historic role, the original Marine Lab was designated a National Historic Landmark as the first permanent marine science station in the nation. In the 1980s, new areas of study in oceanography developed as advances were made in basic sciences and technology. Marine chemists began searching coral reefs worldwide, looking for unique chemical compounds produced by marine plants and animals. Small samples are taken to test for their effectiveness in combating and curing human diseases. So far, compounds have been identified that inhibit inflammation, pain, and cancer cell growth. Marine physiologists ventured to Antarctica to help study how life survives under the most extreme weather conditions on Earth. Focusing on seals and penguins, the researchers developed tiny instrument packages that make physiological and physical measurements, while the animals swim and dive for food. They have found that the diving animals have specialized systems for maximizing oxygen use and regulating body temperatures. Marine geologists and geophysicists, in pursuit of understanding the mechanisms that drive plate tectonics, volcanoes, and earthquakes, continued deep-sea explorations using newly developed sophisticated electronic instruments. They also extended their monitoring by establishing a global network of land-based seismic instruments to measure deep Earth activities. Coastal oceanographers and engineers responded to increasing populations along the coastline by studying the processes that move sand on and off beaches and devising means for protecting natural resources and human developments. Strategies for placing and maintaining sand on beaches were tested and applied along California's coastline. Marine biologists and ecologists also developed programs for monitoring the health of nearshore kelp beds and other habitats, in efforts to assess the effects of fishing and pollution from spills and runoff. They have found that marine life off California is greatly depleted today, and that only by creating protected areas can there be any hope for recovery of many species. In 1986, Edward Freeman became director, with the aim of expanding international research partnerships and worldwide research projects. Scripps joined in several large-scale, multi-million-dollar global monitoring programs involving dozens of investigators and multiple observation systems. Many new faculty and research scientists were recruited to join in these efforts. For the World Ocean Circulation Experiment, instruments were developed to accurately track the circulation and weather conditions of the ocean surface, while other devices were designed to measure subsurface conditions. They can drift underwater for weeks and then surface to report back their data. During the Central Equatorial Pacific experiment, a multitude of ships, buoys, planes, satellites, and field stations measured the exchange of heat and energy between the ocean, atmosphere, and clouds. The scientists determined that high-altitude clouds limit the amount of solar heating, thus regulating sea surface temperatures and evaporation. Using a similar deployment of research platforms, the Indian Ocean experiment focused on the effects of air pollution on the formation of clouds and solar heating. The researchers found a dense brownish haze covering the northern Indian Ocean for much of the year that reduces solar radiation by as much as 10%, which is altering weather patterns and may have an impact on marine life abundance. During the late 1980s and 1990s, major facilities were developed at Scripps, including a new pier to replace the 70-year-old wooden pier that was damaged by heavy storm waves, and a new aquarium and museum, funded largely by a grant from the Stephen and Mary Birch Foundation. With its Hall of Fishes that offers views of marine life and naturalistic displays, including a walk past a giant kelp forest, and a museum of ocean and earth science exhibits, the Birch Aquarium at Scripps immediately became a preeminent San Diego attraction. More than 350,000 people a year visit the Birch Aquarium at Scripps. In 1995, research vessel Roger Revelle was launched into service at a Louisiana shipyard amid the flourish of a Navy ceremony. Christened by Ellen Revelle, RV Revelle, at 275 feet, is among the nation's largest and most modern oceanographic ships, capable of working in all the world's oceans while accommodating 37 scientists and a crew of 22. In 1998, Charles Kennel became Scripps director. Kennel has initiated specialized research centers designed to apply Scripps's research to societal and environmental needs in new ways. Marine biodiversity and conservation, marine microbiology and genomics, and coastal processes and pollution. To implement these programs, new faculty have been recruited and new facilities have been built, including one of the world's largest computing systems dedicated to ocean and atmospheric sciences, and an immersive, state-of-the-art visualization center for data analysis and computer modeling. One result has been increased graduate student admissions, which expands the institution's research capabilities. Scripps Institution of Oceanography's accomplishments are diverse and numerous, but perhaps its greatest success has been to combine scientific research, teaching, and direct contributions to society. Scripps faculty, students, and staff have developed new theories and technologies, made a wide range of scientific discoveries, and served as advisors to the state of California, the federal government, and international agencies. Today, Scripps Institution is a leader in ocean and earth science research and environmental monitoring, from local and regional studies to global observations. In these times when environmental considerations are causing concern around the world, Scripps continues to provide sound scientific information to assist the public and policymakers in making informed decisions. 100 years ago, William Ritter began a journey to better understand the interrelatedness of organisms and their environments. A journey that has led Scripps scientists to understandings of the interrelatedness of all Earth systems, water, air, land, and life. As Scripps Institution of Oceanography embarks on its second century of exploration, it is guided by its mission to seek, teach, and communicate scientific understanding of the oceans, atmosphere, Earth, and other planets for the benefit of society and the environment. What challenges lie in store for the 21st century? Not even a visionary such as William Ritter could have imagined how far the institution he founded could go and what it would discover along the way. Considering all that Scripps Institution of Oceanography has done so far, the future seems limitless.